Everyone, I am Dr. Siraj Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about atomic structures. So my friends, what is atomic structures and why it is important? You know, all matter is composed of atoms. Understanding the structure of atoms is critical to understanding the properties of matter. You know the history of the atom in 1980 80 1808, John Dalton suggested that all matter was made up of tiny spheres that were able to bounce around with a perfect elasticity and call them atoms. You know Dalton's atomic theory. Atoms of element X and atoms of element Y combine together forming compound of element X and compound of element Y, like that. Then you know the subatomic particles. What is the subatomic particles like electron, proton and neutron? Their masses, charge and charge unit. You know electron minus 1, proton plus 1 and neutron 0. So 1898, John Thomson found that atoms could sometimes eject or a far smaller negative particles which he called an electron. And this is based on the cathode ray experiment. You know cathode rays tube. There is a magnetic portion, voltage, anode and cathode, and it detected on the basis of fluorescent screen. So A, you know alpha, beta, gamma, this is the rays. Then J.J. Thomson measured mass by charge of electrons and he got the Nobel Prize in physics in 1906. Charge of an electrons, you know the Millikan eye drop experiments. Then 1910, Rutherford, carrying out his famous experiment, they fired helium nuclei at a piece of gold foil which was only a few atoms thick. They found that although most of them pass through the about 1 in 10,000 heat through the alpha particles, you know the beta particles, about his experiments. Then you also know the Plum-Pudding model of an atom. A sphere clouds of the positive charge and electrons. Just visualize in your brain. So results of foil experiments, if the Plum-Pudding models had been corrected, electron scattered throughout the positive charge. But the actual result is different. Most of the particle is not passing directly. Means something is different. Then a nuclear atom viewed in a cross section, you know the nucleus is 10 to the power minus 13 centimeter. So Rutherford model of an atom, if you see the location of the subatomic particles, then you will understand the proton neutron. So atomic radius 100 picometers and nuclear radius 5 into 10 to the minus 3 picometers. So atomic structure, the atoms are composed of protons, positively charged particles, neutrons, neutral particles, electrons, negatively charged particles. Protons and neutrons are located in the nucleus. Electrons are found in orbitals surrounding the nucleus. Think about the helium atom, think about the shell, then think about the proton, which is inside the nucleus, and then electrons, and then think about the neutrons. Every different atom has a characteristic number of protons in the nucleus. So atomic number is equal to number of protons. Atom with the same atomic number have the same chemical properties and belong to the same element. You also know each proton and neutron has a mass of approximately 1 dalton. The sum of protons and neutrons is the atom's atomic mass. You also know about the isotopes. What is the isotopes? Atoms of the same elements that have the different atomic mass number due to different number of neutrons. So atomic structure, atomic number and atomic mass. If you see the helium, the number of protons and neutrons is an atom. At the bottom, a number of protons in an atom is up. So number of electrons is equal to number of protons. So atomic number, number of protons in nucleus. Then mass number, it is denoted by A, number of protons plus number of neutrons is equal to atomic number plus number of neutrons. So isotopes are the atoms of the same element with a different number of neutrons in the nucleus. So mass number, atomic number, you can imagine, you have seen in your book, proton, deuterium, tritium. What is the difference? Only mass, atomic numbers. For the carbon, 6 protons, 6 neutrons, 6 electrons. If you have carbon 13, 6 protons, 7 neutrons and 6 electrons. If you have carbon 14, 6 protons, 8 neutrons and 6 electrons. So two isotopes of sodium have different number of protons, neutrons and electrons. Protons are same, neutrons and electrons. So if you have sodium 1123, means 11 electrons, 11 protons and 12 neutrons. If you have sodium 1124, so 11 protons, 13 neutrons and 11 protons. So 1913, Niels Bohr's studies under Rutherford at the Victoria University in Manchester. Bohr refined Rutherford's idea by adding that the electrons were in orbit, rather like planet orbiting the sun, with each orbit only able to contain a set of number of electrons. So multi-electron atoms, you can see, you can see and you can go through the book, you will see the K shell, L shell, M shell, N shell, number of electrons. And then the 1s, 2s, 2p, 3s, 3p energy level. It is based on the the shape of an orbital, 2p orbital and 3d orbitals like that. You also know the spherical, dumbbell, double dumbbell like that. So Bohr models of an atom, electron can have only a specific energy value. Light is emitted as electron moves from one energy level to lower energy. So energy is equal to minus RH, 1 by the square. You know the N, principal quantum number. You know about the principal quantum number. And RH, Rydberg constants. So if you read the books, you will get the Bohr models of the atoms, how it is, everything is fixed. Then Bohr models of atom, ground and excited state, two excited state and ground state. In the Bohr model of hydrogen, the lowest amount of energy hydrogen's 1 electrons can have correspond to the being in the atom is equal to 1 orbit. We call this its ground states. When the atom gains energy, the electrons leaps to a higher energy orbit. We call this an excited state. The atom is less stable in an excited state, and so it will release the extra energy to return to the ground states. So either all at once or in several steps. Now, you know the helium lamp, you know the slit, you know the prism. Then if you imagine this in photographic film, so line spectrum, this indicates that according to Bohr model of atom, hydrogen spectrum, every hydrogen atom has identical output. So every hydrogen atom can undergo the same energy transitions. However, since the distance between the orbits in an atom are not all the same, no two leaves in the atom will have the same energy. The closer the orbits are in energy, the lower the energy of the photons emitted. Lower energy photons, longer wavelengths. You also know we get an emission spectrum that has a lot of lines that are unique to hydrogen atoms. So if you want to look at this picture, you go through the books and see the hydrogen spectrum. The Bohr model of atom, hydrogen spectrum. So now you know the N1, N2, N3, N4, N5, and this is your principal quantum. So on the basis that you know the N1 Lyman series, N2 Balmer series, Paschen series, and bracket series, then you can calculate the energy of photons, final minus initial. Then you can see the line spectrum of some elements like sodium, like emission of the sodium atom. You know the neutral atoms have the same number of protons and neutrons. Ions are charged atoms, cations or anions, you all know. The ion is formed when an atom or group of atom has a net positive or negative charge. If a neutral atom loses one or more electrons, it becomes a cation, and oppositely anions. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel.